Okay, students, we are now starting the next topic, Mod 2 Topic 1. Okay, and this first one is about circles. Okay, so as it says, do the warms at the bottom of the page down here. Let's see what you can remember from 8th grade geometry part right there, or earlier in the year when we reviewed this. So go ahead and pause the video, answer what you can there, and then I will fill in the answers for you. Okay, angles 4 and 6 right here are, notice these lines M and N are parallel. How we identify parallel lines, we have an arrow in the same directions. The arrow at the end, naming lines M and N with lowercase letters, does not count. It's got to be written like this, or it could be filled in. Then we know we have parallel lines. Either way, doesn't have, the arrows don't have to be filled in, but they could be. So you need to know that there's no difference between a filled in arrow versus not filled in arrow. Angles 4 and 6 are called alternate interior angles, AIA. Remember, they're interior because they're inside the parallel lines. 3, 4, 5, and 6 are interior angles. Remember, the word alternate means diagonal from each other. So alternate interior angles. The other pair of alternate interior angles are 3 and 5. Okay. Angles 3 and 7 now. 3 and 7 are also congruent, but they are called corresponding angles. Okay. The other pairs of corresponding angles are angles 2 and 6, 1 and 5, and 4 and 8. Okay, so there's 4 pairs of corresponding angles, 2 pairs of alternate interior angles, and 6 and 8. Since we're already dealing with 6 here, 8 we can put there as well. Vertical angles. All vertical angles are equal. Okay, so since vertical angles are equal, we know 7 and 5 is a vertical angle. We know 3 and 1 is a vertical angle. So they're all equal. And then we also have 2 and 4 right here are vertical angles. And 5 and 7 are already listed, 6 and 8 are already listed. Okay, so there's your 4 pairs of vertical angles. Okay, so that's some review. Now go 2 pages ahead. And come on down here. Vocabulary. Most of this section is about vocab. Central angle. Key word here is central, center. It must be touching the center. So this 45 degrees is called a central angle. Notice this vertex is at the center. Q is the vertex. So angle AQC, remember the vertex is always the middle letter. And then an arc is part of a circle, like arc AC. Arc AC. You notice it's got an arc symbol. It's not a segment, it's an arc. The central angle, 45 degrees, equals the measure of the arc itself. As it says here, the arc is equal to it. So the central angle, the measure of the central angle, equals the arc measure. Okay? That's what that's saying right there. Central angle equals the arc measure. And you know that. You're going to use this in Mod 4, Topic 1, when we talk about areas of sectors, segments, and also talking about arc length. You're going to know central angle equals the arc measure. Go to the next page. Okay, remember this is called a semicircle. And semicircles are 180 degrees. So both directions you have semicircle. Okay. Now we're going to talk about arcs, major arc and minor arc. A major arc and minor arc. Minor arc is between 0 and 180 degrees. Notice it does not include 0 and 180. A major arc is between 180 and 360. Okay, if they only give you two letters, as I do right here, this has to be a minor arc. Okay, if it's a major arc, they're going to use three letters. Okay, so major arc here could be A, C, B. That is so A, C, B, which is the same thing as saying BCA, arc BCA. Remember, that's an arc symbol, not a segment. Segments only have two letters. So arc, you can call it arc ACB or BCA. It tells the order it goes in. It starts at A, goes through C, ends at B, or starts at B, goes through C, and ends at A. Those are greater than 180. Okay, and less than 360. Whereas arc AB is a minor arc. Okay, whatever that length is between that. So we cannot call AB, this is not going to be AB, because it can go either direction, but AB, if it's only got two letters, has to be the minor arc. So it's only going to be, well, let's change this to purple so you can talk about colors. So arc AB cannot be this purple one, because that's more than 180. If it's only got two letters, it's got to be a minor arc. So it's the blue one. Okay, difference between major and minor. All right, another vocab, secant of a circle is a line that could be a line, ray, or segment. Line, ray, or segment that intersects a circle at 2 points. So this is a secant right there. A chord is a segment whose endpoints are on the circle. So C to D itself is called a chord. If it goes past the circles, the edge of the circle, now it becomes a secant. If it's from CD, any 2 points, connecting any 2 points on the circle, is called a chord. What do you think the longest chord is in a circle? Extra credit point if you can tell me. It is the diameter. It is always the longest chord. So in this case, FG would be the longest chord in the circle. The closer it gets to the circle, what do you think happens to the chord? Does it get longer or shorter? Well, if the longest chord goes through the center, then as it gets closer to the center, it's going to become longer. So since chord AB is closer to the center of the circle than chord CD, then chord AB is going to be longer than chord CD. Okay, so secant and chord vocabulary again. All chords are segments. There's a segment symbol. Secant can be a line, ray, or segment. It's not just a line. Okay, go 2 pages ahead. Angle and arc relationships. Just quickly reviewed on vocabulary. Angles POM and DOB right there are vertical angles. Okay, remember they're right across from each other. They create 2 lines if I was to extend them. And they're across. Those are vertical angles. Okay, and then they give you 2 more right there. And now it says here, consider the conjectures and determine who's correct. Faith says all vertical angles are congruent, which we just said, and they have to be 90 degrees. Trey just says all vertical angles are congruent. So the question is, do they have to always be 90 degrees? Here's an example. Right there, those are congruent. They're vertical angles, those aren't 90 degrees. Those 2 are congruent, they're vertical angles. Okay, so Trey is correct. Okay. The angles of a linear pair. So vocabulary, linear pair again, reviewing vocabulary. Angles 1 and 2 are a linear pair. What's the key word? They form a line. There's my line. And a pair, 2 angles only, not 3, not 4. So this right here, there's a line. If I have this one, and this one, if I add that plus that plus that plus that, that creates a line, but it's not a pair of angles. So that even though it creates a line, it is not a linear pair. It can only be 2 angles. And of course, all lines, angles of that create a line is 180 degrees. So it says the sum is 180. Okay, now go to the next page. An inscribed angle. So we got inscribed angles, arcs, and tangents. An inscribed angle, it says right here, is an angle whose vertex is on the circle and whose sides contain chords of the circle. So basically, you want to just think of the angles on the circle. An inscribed angle is the angle on the circle. So PMD. There's the angle right there. It's on the circle. That's called inscribed angle. Okay. EOM is not an inscribed angle because the angle is inside the circle. Remember, it's touching the center where the vertex is, so that's a central angle. In order for it to be an inscribed angle, the vertex must be on the circle. Okay, let's just draw in some more. So I have that one there, that one there, and that one there. Okay. So PLE is an inscribed angle. The vertex is on the circle. We have EBP would be an inscribed angle because the vertex is on the circle. We have PM, we'll call this H. PMH is an inscribed angle because the angle is on the circle, not inside the circle. Okay, so inscribed angles. And an inscribed angle is always equal to half of its intercepted arc. And we'll get into that here. Okay, so now we talk about the inscribed or the intercepted arc. The intercepted arc is the part of the circle that lies in the interior of the angle with its endpoints at the intersection of the angles in the circle. So let's go back up here. When I have that inscribed angle, this is called the intercepted arc. Okay, so if I just go out where that angle is, where those two chords, and then connect those points at the ends of the chords, that's called the intercepted arc. Okay, so if I looked at PMH, remember that's the inscribed angle. I connect the two where they end, and this is the intercepted arc. Okay, so if I said this was 70 degrees right there, the intercepted arc, so arc PH. Now I'm not going to call it PH because that's going to tell me, it's not going to tell me which direction to go. So I'm going to say PDH. So P through D next, and at H, that arc equals double the inscribed angle. So that's going to be 140 degrees. So I could also call it PEH, or you don't usually use 4 letters. You know if they were PEDH, but usually only use 3 for a major arc. Okay, so just know that they could use all 4 PEDH, but they don't have to. Cut 3 is the common one. But the intercepted arc is always double the inscribed angle. Okay, vocab. Go 2 pages ahead. Okay, the word tangent. Okay, a tangent to a circle is a line that intersects the circle in exactly one point, called the point of tangency. So line RQ intersects, only touches the circle once, so it's a tangent line. Point Q is called the point of tangency. Where it actually touches the circle right there is called the point of tangency. So Q be the point of tangency. Now, what's their error they have here? They cannot use a capital letter at the end of a line. It has to be lowercase m. So you can call it line M that way, or line RQ if you pick 2 points on the line. So that was an error in the book again. Okay, so here, if we look here, we got 2 tangent lines. Call it line QL. There's no way we can name that line. And the point of tangency is L. Now, with tangent lines, they're always 90 degrees to the center of the circle. So if I connect it to the center of the circle right there, it always will be 90 degrees. It's another thing to know about it. So here, line QG is also a tangent line. Okay. Notice they did not connect it, G, the point of tangency, to the center of the circle, but if I connect it now that has to be 90 degrees. Whenever I connect the point of tangency to the center of the circle, that angle formed is 90 degrees, called perpendicular or right angle. You gotta know perpendicular, right angle, 90 degrees, all the same thing. Okay, a circumscribed angle has 2 sides. It's 2 sides tangent to the circle. So they're calling this angle right here circumscribed angle. Okay, circumscribed means about or around. It's around the circle, outside the circle. A lot of people just call it an external angle, but this book calls it a circumscribed angle. It's an angle outside the circle. Okay, and according to this one, the circumscribed angle can only be 2 tangents. All right, so vocabulary. Go ahead and go ahead 1 page. Now, what I want you to do is pause the video, and I want you to draw an example of each of these on this page, and then go on to the next page as well, and do that as well. And so when you're done doing that, go ahead and hit play, and I'll have drawn these answers in for you. Okay, all circles are similar. Center circle, here's another circle with the center right there. It's just dilated bigger. Vertical angles are congruent. Vertical angles are congruent. Could have done that. Could have done this one. Remember, I used 2 because those angles are different degrees. When you add the measure of 2 angles, X and Y, the sum of the measures of another, the sum is the measures of another angle, Z. Okay, so let's call that angle X, angle Y, right there, and then the whole thing would be angle Z. When you add the measure of 2 arcs, X and Y, so there are arcs on a circle. So measure of 2 arcs, X and Y, then the sum of the measure of the sum is the measure of another arc, is Z. Okay. I don't like how they name these arcs with 1 letter ever. I would never do that. When 2 parallel lines are crossed by a transversal, remember 2 parallel lines, that's not parallel until I put those arrows on the same direction, the same number of arrows, cut by a transversal. Now I have 2 parallel lines cut by a transversal. Alternate interior angles are congruent. There's 1 pair of alternate interior angles. There's the other pair of alternate interior angles. When a transversal crosses 2 parallel lines, so again we have the same situation. Corresponding angles are congruent. Okay, so name the corresponding angles. This is from your warm-ups. There's a pair. We know that those are vertical angles, so then there's another pair. There's a pair. And since we have vertical angles, that has to equal that. And here's the other pair. Okay, corresponding angles are congruent. go to the next page. When an inscribed angle, remember an inscribed angle is one that's on the circle, such as this. An inscribed angle intercepts the same arc as the central angle. So that means here's the central angle. Central angle has the same arc. Okay. The inscribed angle, which is this right here. So if this, whatever this is, let's call it x degrees, then the inscribed angle is half of it. Central angle measure. Okay, and the arc measure itself, arc AB, is the exact same as the central angle. So if that's 6 degrees, that's 6 degrees, and then the inscribed angle will be 30 degrees. Two inscribed angles that intercept the same arc have the same measure. Okay, so let's say I take, call it AB again, and D, call this C. Connect it like that. So two inscribed angles. Remember this is an inscribed angle, that's an inscribed angle. They intercept the same arc. So remember, notice both their arcs is AB. The arcs have the same, so two inscribed angles that intercept the same arc have the same measure. So it's saying that this angle is equal to that angle. So if, say, for example, this is 60 degrees, then this is 30 degrees, and this is 30 degrees. That's what that's saying. When an inscribed angle intercepts a semicircle arc. Remember, semicircle must go through the center of the circle. An inscribed angle intercepts the semicircle. Then that measure is 90 degrees, because we know the intercepted arc right here is 180. And since it's an inscribed angle, it's half of 180, which makes it 90. And you always identify that with a right angle symbol, perpendicular. The angle formed by a tangent line in a radius is 90 degrees. So remember, a tangent line is when it only hits it one time. We'll call that there, we'll call that D, and that P. So now if I go ahead and, so the tangent line, the angle formed by the tangent line, which is line M, and a radius of the circle, there's my radius, is 90 degrees. Remember, all tangents are 90 degrees or perpendicular to the center of the circle. It's got to connect to the center of the circle, not somewhere else. It'll be 90 degrees. All right, go to the next page. And we're just going to go over this vocab right here and then see we're done right there. So I want you to see about putting the correct letters over here that match up with these letters here. So pause the video, do that, and then check it afterwards here. Okay, so A says a presumption that something is true or false. The only possibility is conjecture. We'll wait on that. A line that intersects a circle at exactly one point. We just did that. Tangent. So it's B. So it's out. An angle that has two sides tangent to a circle. It's that circumscribed angle. C. An angle with a vertex that is on the circle and the sides that contain the chords of the circle. That's my inscribed angle. Inscribed D. The arc with a greater measure. That's the major arc. E. The arc with the lesser measure. That's the minor arc. H. A line that passes through 2 points of a circle. It's a secant. F. The arc of a circle with endpoints that are intersected by two rays of an angle. Okay, I'm going to raise the angle. That's my intercepted arc, G. And therefore, A is that can be true or false conjecture. Okay, that ends this lesson right here. You see there's a bunch of vocabulary. You might want to watch this a couple more times to get all vocabulary down that you still don't know. A lot of it should have been reviewed if you did your 8th grade geometry, but if not, you got a lot to learn right here because we'll be using this all throughout the year. Okay, and onward when you talk about circles.